Hi there, friends. My name's Matthew. I'm the C# artisan. And in this video, we're going to take a look at the difference between delegates and lambda expressions. Now, these two concepts are closely related. And when I go and do a little searching on the internet, I find some kind of confusing and even incorrect information about how they relate and the differences. So I thought I would just take a little time to try to clear it up so that you have a good understanding of these two very important and very useful C# programming techniques. So I thought the best way to start is with a practical example. Let's say you want to launch a background thread to do some work, and you want to do it explicitly by creating and running a thread. So we're using the system.threading namespace here, and the way you do this is you say thread t equals new, and then when you call the thread constructor, we can pass it this thing called a parameterized thread start. So what on earth is that? A parameterized thread start is a delegate that's defined in the system.threading assembly. So we can go look at that definition. So let's just say parameterized thread start. We'll just name it and go to definition. And we can see here in the system.threading.thread assembly, we've got this delegate defined. So a delegate is really just a formally named method signature. What this means is any function, regardless of its name, that follows this pattern, that returns void and takes a nullable object as its input, qualifies, it meets the definition of a parameterized thread start, and therefore it can be used to start a thread. That might be a little abstract, so let's just go implement it, and I think it'll become clear. So here in my program class, we'll say private static void, and I'll call this thread proc. So now we have a named method, threadproc, which returns void and accepts an object. So that'll work for our thread start, a parameterized thread start. So let's go back, clean this up. So thread t equals new, and we're going to pass it in the threadproc method in the constructor. Then we can go ahead and start our thread. And it'll accept an object, and you'll see why. I'm just going to pass it the number 3 here. And then we can say t.join, which is a way to block and wait for the thread to complete. So now our little test is almost done. All we have to do is implement our thread proc. But again, we're creating a thread, starting it, and waiting for it to finish. So what do we want to do here? Let's do this. So we'll say int loops equals, and we're just going to cast that input variable as an integer, and int current loop, start off at 1, and then we can say while current loop is less than or equal to loops, and we can just write a message out. So console.writeLine. We'll do a little string interpolation. Hello from loop, current loop, out of loops. Then we'll increment our loop counter, and just to make it a little more dramatic, we can say thread.sleep, and we'll let it wait for a second between each one. So now we've got our thread proc, our parameterized thread start delegate implemented. Let's go ahead and run this. I'll click delegate test. It's going to show up on this screen. Let me grab it. Okay, welcome to the delegate test utility. Press enter to start. What is it doing? What did I do wrong? Oh, greater than or equal to. How about less than or equal to? It helps when you type properly. Try this again. Okay, press enter to start. hello from loop 1, 2, and 3. So there you go. That is passing a traditional function, name delegate, to something that requires a delegate. So the next evolution in this technique, taking us towards Lambda functions, is to use what's called an anonymous delegate. And that's where you don't declare this function out here, you actually kind of inline it here. And here's the syntax for doing that. We would say new delegate obj. So we're now kind of declaring an anonymous delegate on the fly, and then the body of our thread proc goes right in there. Whoops. All right, and now we can get rid of our thread proc. We no longer need it. So this is the anonymous delegate style of doing the same thing. So why don't we go ahead and run it and verify it. 1, 2, 3, it works. So again, that's the anonymous delegate. So to get from an anonymous delegate to a Lambda is really a very simple change. What we're going to do here is we're going to say we're calling a function which expects some sort of parameter named O, and we just give it an arrow function, just like that. And then we'll rename this. So why did I rename it from obj to O? I didn't have to. But in a lot of the examples of Lambda expressions or Lambda functions, it is kind of a style to trim these variable names down to their bare minimum. So in keeping with that, I went with O instead of obj. Doesn't really matter. So this is a Lambda expression, which means, hey, I'm kind of calling this anonymous delegate that's going to have O as its input, and the arrow function points to the method body. It should work just the same. All right, let's press enter. 1, 2, 3. So there you have it. 3 different ways of doing the same thing. The traditional named delegate, the anonymous delegate, and the equivalent Lambda expression. That's really all there is to it. So you're left with the question of, well, which do I choose? What should I use? Many of the help files and examples on the internet and in the Microsoft Docs, they favor Lambda functions because they're cool looking, right? It's very concise. And in many cases, that is what I go for. So for example, if I've got a list and I want to do list.find, which requires this special delegate called a predicate, I just inline it with an arrow function. However, if I'm doing something like starting a thread, where the body of the thread function might be pretty complicated and where there are some multi-threading and concurrency issues, in that case, I tend to favor just lifting this out into a thread proc and keeping a real clear separation of duties about what is launching it and what is its internal implementation. It's up to you. You can choose, but now at least you know the difference between these 3 techniques. Hope that's helpful. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.